Hi, welcome to a brand new section, Visualization with Seaborn and Pandas. In this section, we will first learn about stacking area charts to discover emerging trends, and then we will dig in and find the difference between seaborn and pandas. After that, we will perform multivariate analysis with seaborn grids and uncover Simpson's paradox in the diamonds dataset with seaborn. So let's start with the first video that deals with stacking area charts to discover emerging trends. In this video, we will use data gathered from the popular website meetup.com. Using a stacked area chart, we will show membership distribution between 5 data science-related meetup groups. Stacked area charts are great visualizations to discover emerging trends, especially in the marketplace. It is a common choice to show the percentage of the market share for things such as internet browsers, cell phones, or vehicles. Now to start with, let's first read in the Meetup dataset, convert the join date column into a timestamp, place it in the inbox, and output the first 5 rows. You can see that we have the exact date and time when each person joined each group. Let's get the number of people who joined each group each week. Here, we group by each week. Offset set to W and Meetup group and return the number of signups for that week with the size method. As you run this code, you will find the resulting series is not suitable to make plots with pandas. We need to unstack the group level so that each Meetup group has its own column of data. We set the option fill value to 0 so that groups with no memberships during a particular week will not have missing values. This data represents the number of members who joined that particular week. Let's take the cumulative sum of each column to get the grand total number of members, using the CumSum method. Many stacked area charts use the percentage of the total so that each row always adds up to 100%. Let's divide each row by the row total to find this percentage. For this purpose, we use the sum and division methods. We can now create our stacked area plot, which will continually accumulate the columns, one on top of the other. Let's add the code in the next line. Notice that Pandas allows you to set the access limits with a datetime string. This will not work if done directly at matplotlib using the ax.set_xlim method. And here we have the stack area chart generated. As you can observe, the starting date for the plot is moved up a couple years, because the Houston R users group began much earlier than any of the other groups. Although typically frowned upon by data visualization gurus, pandas can create pie charts. To create pie charts, let's first create the data. Here we select every 3rd month of data, beginning 18 months prior to the end of data collection. We use the asFreq method, which only works on data frames with datetime values in the index. The offset alias 3ms is used to represent the start of every 3rd month. Because group CumPCT is aggregated by week, the first day of the month is not always present. We set the method parameter to bfill, which stands for backfill. It will look back in time to find the first day of the month that has data in it. We then use the toPeriod method, which also only works with date times in the index, to change the values in the index to a pandas period of time. Finally, we transpose the data so that each column represents the distribution of members in the Meetup group for that month. We now have the data at hand, which we'll use to plot on the pie chart. From here, we can use the plot method to create the pie charts. Let's add the code. Here we define an array using the plot method. We specify the layout, labels, colors, and subplots. Let's run this code. So we have our pie chart ready for analysis. Amazing!